So exponential word problems almost always work off the growth decay formula. A equals P e to the RT, where A is the ending amount of whatever you're dealing with, P is the beginning amount of the same whatever, R is the growth or decay rate, and T is time. And, A equals P e to the RT, or A equals P e to the KT, or Q, okay. So certain bacteria, given favorable growth conditions, grow continuously at a rate of 4.6% a day. Find the bacterial population after 36 hours if the initial population was 250 bacteria. So using the formula A equals P e to the RT, I can see that the beginning amount was P equals 250. The growth rate R is 0.046, and the time T is 36 hours over 24 hours, which would equal about 1.5 days. So plugging in all the known values, we come up with the equation A equals 250 times e to the 0.046 times 1.5. And evaluating that, we will come up with about 268 bacteria after 36 hours. Radioisotopes of different elements have different half-lives. Magnesium-27 has a half-life of 9.4 minutes. What is the decay constant for magnesium-27? Round to 5 decimal places. Since the decay rate is given in terms of minutes, then the time t will be in minutes. However, it doesn't really matter what the beginning amount is, because it would still have gone from 100% from whatever I started with to 50% of that amount. So it really doesn't matter how much you start with. Because of this, we calculate the decay constant after 9.4 minutes, at which only half the amount will remain. So anyway, you end up with the equation 0.5 equals e to the 9.45 r. To solve for the decay constant, you have to take the natural log of both sides to come up with the rate of negative 0.0733 per minute. One very important exponential equation is the compound interest formula. A equals P to the quantity of 1 plus R over N to the NT, where A is the ending amount, P is the beginning amount or principal, R is the interest rate, which is expressed as a decimal, N is the number of compoundings a year, and T is the total number of years. Okay, suppose that you plan to need 10,000 in 36 months' time when your child starts attending university. You want to invest in an instrument yielding 3.5 interest, compounding monthly. How much should you invest? To solve this, I have to figure out which values go with which variables. In this case, I want to end up with 10,000. So A equals 10,000. The interest rate is 3.5%. So as a decimal, R will equal 0.035. And the time frame is 36 months. So to convert that into years, you divide that by 12, which equals 3. So T is 3 years. And since the interest is compounded monthly, N equals 12. The only remaining variable is P, which is how much I start with. So in this case, we need to solve for P. So we plug in all the known variables to get the equation 10,000 equals P to the quantity of 1 plus 0.035 over 12 to 36. Now, at this point, you need to divide the entire quantity on the right-hand side, so it's to take it to the other side. Otherwise, you'll end up with a round-off error, which can change the value. So when you do that and you simplify, you'll need to invest about 9,000 for